Hi, good evening. We're going to get into module 15, which is about factoring polynomials. Factoring is actually reversing the multiplication process. So let's start with lesson 15.1, which talks about different techniques of factoring polynomials. We'll get into all those techniques one by one. So factoring is actually reversing the multiplication process. It's not exactly division. Talked about the reversing of multiplication is division, but it's not division. Reversing is actually factoring it. Say, for example, I have a number 6. How did I get that 6? What are the two numbers that will multiply to give me a 6? It could be a 2 and a 3, or a 1 and a 6. So I'm factoring the 6, writing it as multiplication of two numbers, right? So this is factoring 6. So I'm trying to find the factors of 6. So when I talk about factoring polynomials, I'm trying to find the two polynomials or three polynomials that multiply to give me the product, which is my polynomial that I'm going to factor. All right. So we talked about different polynomials. Different polynomials, we can use different techniques. One technique or more than one technique put together will help us factor that polynomial. So technique number 1 is factoring by using a GCF, meaning a greatest common factor. I'm going to be pulling out a greatest common factor, which is usually a monomial. All right, so from the polynomial, I'm going to pull out a monomial. In other words, pulling out a GCF is reversing your distributive property. Distributive property is actually your multiplication. So I'm reversing my distributive property. So we have done this while multiplying a monomial and a polynomial, right? So let's take this multiplication problem. We said that factoring is reversing your multiplication. So what did we do when we multiplied our monomial and our polynomial, right? So when I multiply, I'm distributing the 2x. 2x times 3x squared is 6x cubed. 2x times 2x is a 4x squared plus 4x squared. 2x times negative 4 is negative 8x. So when I distributed the monomial to this trinomial, I got another trinomial, which is my product. So this is my product. So I want to reverse this multiplication process. Reversing the multiplication process, I start with my product, which is 6x cubed plus 4x squared minus 8x. So when I reverse this distributive property, I want to pull out a greatest common factor. The greatest common factor I have in between these three terms. All right. So in these three terms, I have coefficients and I have variables also. So when I talk about greatest common factor, I need to pull out a greatest common factor between the numbers and also the greatest common factor between the variables. All right. So between the numbers, 6 is 2 times 3, 4 is 2 times 2, and 8 is 2 times 4. So when I look at it, the greatest common factor between the three numbers is a 2. Now I'm not done just by pulling out a greatest common factor between the numbers. I also have to pull out a greatest common factor between the variables. So when I look at the variable part of each term, x cubed, the factors are x times x times x. The next term is x squared. The factors are x times x. The next term is x. It is just x times 1, right? So I have these factors. The greatest common factor between the three variable part is 1x, right? I have 1x that's common between the three. So 2 and an x together, I'm going to pull those factors out. So 2x is what I'm pulling out of these three terms. So I have to write the other factor. What is left? Once I pull out a factor of 2x amongst all these three terms, what is a factor that is left of these three terms? So when I pulled out a factor of 2 from the number 6, I am left with a 3. And when I pulled out the common factor of x from the x cube, I'm left with an x square. So 3x squared is what is left of my first term after I pulled out the 2x, which is the greatest common factor. If I multiply it back, will I get 6x cubed? Of course. Now for my second term, I pulled out a greatest common factor of 2, and what is left of that is a 2. So it's a positive. 2 is what is left of the other number. And when I take a look at my variable part, which is x squared, I pulled out an x. What's remaining is an x. So 2x times 2x is going to give me that 4x squared. And when I pull out a greatest common factor of 2, what's left out of the 8 is a 4. So that's a minus, so minus 4. And what's left out of the x is just a 1. Alright, so 4 times 1 is a 4. So I reversed the process by pulling out the GCF. My GCF turned out to be 2x, which was the monomial that we started with earlier, right? And I got back my trinomial, which we multiplied it with the 2x. So I reversed the process of distributive property, and I got back a monomial factor that I took out, which is the GCF of these three terms. And I wrote the other factor, what is left out of the polynomial. So this is one factor, which is 2x times 3x squared plus 2x minus 4. So these two polynomials, a monomial and a trinomial, multiply to give me that product. Okay, so you can check by remultiplying it to see if you get the original problem. All right, so I'm going to do a second example. Say I have 10y cubed plus 20y squared minus 5y. I want to remove a GCF out of these three terms. So when I look at these three terms, I have the number 10. The factors of 10 are 2 and 5. The factors of 20 are 4 and 5. The factors of 5 is a 1 and a 5, right? So now the greatest common factor is a 5. You don't have to do this exercise, but until you get familiar with it, if you guys are really familiar with what a greatest common factor is, go ahead and do it mentally. All right, but until such time, you guys write it down. All right, so I have 10, 20 and 5. The greatest common factor is a 5. Now I have to look at the variable part of each term. So I have y cubed, which is y times y times y. I have y squared, which is y times y. And I have a y, which is y times 1. Now I want to pull a greatest common factor out of these. The greatest common factor is a y. So I'm pulling out a factor of 5y. Alright, so my greatest common factor is 5y. And I have to write what is left of these three terms. So when I pulled out a 5, what's left out of the 10 is a 2. And out of the y cube, I'm left with a y squared. So 2y squared is what is left of my first term. My second term, I pulled out a 5. What's left is a 4. It's a positive 4. Out of the y square, I pulled out a y. So what's left is a y. So it's a 4y that's left out of my second term. My third term, I pulled out a 5. I have a 1 remaining. And I pulled out a y. I still have a 1 remaining. So that's a negative sign. 1 times 1 is a 1 is what is remaining. So this is my factored problem, right? So I found out the factors of this polynomial. So my monomial greatest common factor, which is a 5y, and whatever is left of my trinomial, I wrote it in a parentheses. Now I want to check if I did it correctly. Checking is just remultiplying it to see if you get back your original problem, right? So I have this answer. I'm going to remultiply it, which is again distributing. So 5y times 2y is 10y cubed. 5y times 4y is a 20y squared. 5y times negative 1 is a negative 5y. So I got back my original problem. So my factoring is correct. So this is my answer. I'm checking and verifying whether my answer is correct by doing this step. Okay. So that's factoring by GCF. That is first technique. This is the technique that I will use for every factoring problem. This will be my first step to every factoring problem that we are going to learn in subsequently. Okay. So now technique number 2. Technique number 2 is factoring out a common binomial factor. Okay, so I have binomial factors here. So when we did multiplying the binomial by a binomial, we used a property, we used the method which distributed the terms, right? So we used a distributive property method. We distributed the x to the 2x plus 5. So it is x times 2x plus 5. And we distributed the 3 to the 2x plus 5. So it is plus 3 times 2x plus 5. So I'm having something like that. So I have, if I look at it, I have terms within terms. So when I look at it, this is a factor and this is also a factor. So two things multiplied, plus I have a factor and another factor, a binomial factor. So these also multiplied. So I have a binomial factor that is common between these two, right? The binomial factor is 2x plus 5. So this is what I am arriving at. So what is left of this is an x plus 3. I have an x left out of the first one and I have a 3 that is left out of the second one. So it is 2x plus 5 times x plus 3. So I removed a common binomial factor out of each one of them, right? So this is example 1. So I'm starting with this. I have a common binomial factor which is x minus 3. So I have the x minus 3. I'm pulling it out. What is left? I have to write within a parenthesis. What is left is a 7 from my first and a negative 2x from the second. So these two becomes my binomial factors now. So I pulled out this common binomial factor between these two guys, and what's left out of it, I just wrote it as a separate polynomial. All right. So that's one example, pulling out a common binomial factor. Let's take a look at this one. I have a negative t times t squared plus 4 plus t squared plus 4. I'm not seeing anything there that is timesing it, right? So I see the binomial factor. I'm not seeing any number there like I saw that 2x over there. I don't see a number. I'm going to put a 1. It's 1 times t squared plus 4. Now it's easy for me to pull out a common binomial factor. The common binomial factor is a t squared plus 4. So if I remove that t squared plus 4, all I'm left with in my first term is a negative t, and in my second term it's a positive 1. Okay, so it is t squared plus 4 times negative t plus 1. I can switch it around. This is t squared plus 4, and I can write it as 1 minus t. Right? T minus negative t plus 1, 1 minus t, 1 and the same. So pulling out a common binomial factor. That's technique 2, which we will be using in future factoring problems also. All right. So let's just keep these two techniques in part 1. And the third technique in lesson 15.1, I will continue it in next video so that the video is not too lengthy for you guys to watch. All right. So let's continue in part 2.